So I didn't really have much of a video planned for this weekend, but nevertheless I think it will be interesting. We're going to be taking a look at some of the pictures of less talked about things from TCT, which I think some of which are still really quite interesting. You're also going to want to stick around to the end of the video to check out the really cool little kind of 3D printed gadget that I used at the show in order to help my filming process and to make sure I had enough battery power for the full show. So first off, we have this hot end assembly from a company called Phaetus, P-H-A-E-T-U-S. They are another Chinese brand, and you might be able to tell that based on the fact it looks sort of like a combination of a E3D V6 and a kind of Mosquito hot end, kind of all combined into one. So it's a sort of clone-ish design, but by the looks of it, it does seem to be a reasonably decent piece of kit too. It's not just totally cloned, I think. It looks like they have actually done some design. So they said it was capable of printing at up to 500 degrees Celsius, which in itself is fairly special. It has a titanium alloy heat break, which is also very thin, down to 0.2 millimeters, which is very, very thin. Which obviously provides excellent heat insulation between the kind of hot end and the cold end. The heat block and the nozzle are made out of copper alloy with a high thermal conductivity. Not sure how the nozzle is going to hold up being made out of a very soft material like copper. It's an all-metal kit, which kind of should be self-explanatory at up to 500 degrees Celsius. They do actually have a number of different nozzles available as well, such as ruby nozzles, tungsten carbide, stainless steel, hardened steel, and the normal kind of plated copper as well. Obviously, just by looking at it straight away, you can see a number of design cues taken from other fairly well-known designs. The kind of main aluminium body, I think it is aluminium, looks sort of like an E3D V6 with the hollow kind of middle taken out. That copper part in the middle with the heatsink around it and that very thin tube strongly mimics the Mosquito hot end. And then you've got that very standard looking kind of block at the end with a silicon sock around it, again very E3D V6 looking. And there's also those additional screws or supports that go up between the heat block and the body, which again kind of mimic the Mosquito design. How much of this is directly copied and how much is maybe designed with some improvements or just some cost saving measures and things like that, I'm not totally sure yet. I did have a little chat to them. They might be interested in sending me one, and we'll see how much of it's clone, how much of it's quality, how much of it's copied, how much of it's design. So I mean, I think it'll be a little bit interesting to take a look at regardless of what its source really is. The next thing I want to talk to you about is the Raise 3D E2. Now this is a new printer from Raise 3D, which I believe was announced at the show, if not shortly before, and is a fairly interesting looking machine. It's much smaller than the other current offerings, and is also a fair bit cheaper. Now, it's still a very premium machine, and I think the price point is going to be somewhere around £2,100 to £2,400, somewhere in that region, so definitely on the premium side. But fortunately, it does also have features to match. First off, they have auto bed leveling, which is not a given necessarily at this price point. Their other machines actually don't have automatic bed leveling. They rely on a system which has like a number of screws and comes in theory pre-calibrated from the factory. So nice to see them integrating some auto leveling system. It is an IDEX machine, so you've got dual extruders, dual print heads, obviously being able to print with one at a time so you don't have the problem with purge blocks and all that kind of stuff. You can also, because they're separate heads, they can be each calibrated individually. You don't have a secondary nozzle dragging over your current print. And with that, you can also do like mirror and like dual printing. So you can either print two of the same object or have one of them mirrored. The microwave oven door, the Raise 3D E2 door has a safety feature. So if you open it, either the top or the front, in fact, it can pause the print. It has a removable flexible build plate, which is obviously coming very standard in the industry. If we look through some of the specs for the print, so dual extrusion mode, you get 295 by 240 by 240, and that goes up from 295 to 330 if you're only going to print in single extruder mode. The overall machine size is 607 by 596 by 465 millimeters, so fairly good kind of build volume to printer size ratio. In terms of power, it uses a 24 volt system up to 350 watts. which for me seems slightly on the low side for such a large bed, and dual heaters and a lot of stepper motors. That looks quite limiting. I would expect maybe that bed is going to take a little while to heat up. Print speed is expected to be in the 30 to 150 millimeters per second range, which is a very broad range and generally probably doesn't really tell you that much. The build plate is in fact flexible steel with a Build-Tack surface, which looks like it will be genuine Build-Tack, which is good. They say it will reach 110 degrees C, but as we just looked at, given that power, it seems like that might be quite a challenge, or at least take a little while. They're expecting to support pretty much every material available, including HIPS, polycarbonate, TPE, TPU, nylon, ASA, polypropylene, PVA, glass fibre infused, carbon fibre infused, and all that kind of stuff. Literally the whole lot. It will be available with a number of nozzles ranging from 0.4 to 1 millimeters, so some proper massive nozzles in there. I'm not sure how much benefit you're going to get out of that, given that the power is only 350 watts. It doesn't seem like you're going to be able to stick a really big Volcano E3D heat block on there, which means having a really big nozzle not necessarily going to actually improve your print time in any meaningful way. But obviously we'll have to wait to see and test that and see how that goes. The max temperature does go up to 300 degrees Celsius, so while not being absolutely outstanding, it's still not going to do your really high temperature filaments like PEEK and PEC, but it's kind of great for all your kind of standard range of materials. It does also have a camera and an integrated controller, an ARM processor controller. So with Linux on board, you should be having quite a lot of kind of network connectivity and that sort of thing as well. I did ask about a review, and it looks like the 3DGB IRE, who are the resellers in the UK, might be able to get me one of these in the new year. So that would be absolutely fantastic to be able to take a look at. And I look forward to that, and hopefully you do too. This next thing is less of a product and much more of a process. It actually uses SLA 3D printing and injection molding in order to create fairly advanced kind of injection molded parts. By using an injection molding process in combination with 3D printing, you get kind of the best of both worlds scenario. You have the benefits of being able to create the complex geometry in one-off quantities using DLP printers, while also gaining the benefits of the kind of the isotropic material, so consistent strength in all directions, and as well as being able to use much larger fibers, which you can't have in filament because it would block the nozzle. So this company, whose name unfortunately currently escapes me, so what made this interesting for me is the fact that this company has developed this process, and it seems to be really very effective. The reason it's so effective is, one, the broad range of materials that you can print. That larger off-white object in the front is actually made of flexible material, while those brown parts laying down have a lot of fibers in. You can see those clear materials there, so you get a really broad range of materials you can injection mold into these parts. Not only that, but you can actually make these, I think, quicker than you can with normal injection molding, because your tool, which you're molding into, is disposable. Now, while that's not necessarily ideal in mass production, for small quantity prototypes, it's absolutely perfect because you don't have to invest the large quantity into a tool. Injection molding tools are typically very, very expensive. So overall, this process just seemed pretty interesting to me. At the moment, they're kind of limited by the volume that they can get on DLP machines. As you can see, a lot of what they've done is quite small, but it seems to be a very effective, cost-efficient process. So hopefully we'll be seeing a little bit more of that. So the next one I want to talk about is Anisoprint. I'm not really totally sure how you say it. Anisoprint, I'm going to stick with that. Their 3D printers are capable of basically laying... The special thing about their printers is that they're capable of embedding fibers into their 3D printed parts. Now you might say, hang on a minute, that's exactly what Markforged do. And you'd be right to an extent. There are a lot of similarities between Anisoprint and Markforged. Even the price point is about the same. I believe one of the benefits of Anisoprint, I did talk to them very briefly, but I didn't get a very long chat and we didn't record anything, so I'm not totally sure. This is totally on memory. But I think the special thing about these fibers is that they come coated in the plastic material, or they travel through the plastic material as they're being printed. I'm not totally sure, but that basically gives it better adhesion to the rest of the print, whereas I think on the Markforged they just lay it into the material. So it basically gives it a better bonding, which gives you a little bit extra strength. Well, again, it's a very expensive machine. I'm sure a lot of us are not going to be able to ever afford or own one of these. I think they're really very interesting and certainly pose a lot of potential solutions for engineering applications. So maybe I'll get to try one at work. I don't have a lot to say about this one. There was no one to actually really talk to about it, but I took the picture looking kind of at the wing on the top because I thought that was a very interesting shape for a wing. But after taking the picture and having a closer look at it, I realized that there was something distinctly different about it. The motion components at each end were very different. So on the near side, you have a kind of typical, presumably extruded profile with some machining done to cut down the shapes to exactly what was needed. Maybe it was cast or something. I don't know the exact process. I can't remember. But that part on the far side has clearly been utilizing additive manufacturing. So I just thought this was kind of an interesting application on something kind of, real world application, having dynamic wings on vehicles. And it just shows off one of the capabilities. Presumably they're going to be saving weight here. There might be saving cost depending on tooling and things like that, especially with lower quantities potentially on these kind of supercar models. You generally don't do hundreds and thousands of them. So yeah, I just thought that was quite interesting. So this booth right here was Scan 3D. Scan 3D, I mean, it's a really weird name. But anyway, they were showing off presumably printers that they're reselling, which is the Felix range of printers. So I didn't talk to the resellers too much. I tried to basically talk to the owner of Felix 3D printers, but unfortunately they weren't particularly into doing a video recording. So unfortunately I didn't really get to record anything. As a result, I may have also forgotten a number of details, but basically you can see a number of their machines in the shot here. So these two sitting on the workbench at the front. The one on the right is their kind of entry-level model. It's got no enclosure. It has some basic features. It runs a normal-ish control board with a standard LCD screen. It doesn't have much in the way of smart features, but it's just a kind of fairly solid, well-built 3D printer. It is a little bit on the expensive side, considering it's only like single Z-axis and stuff like that. But it does seem like, well, by looking at the show, it did seem like a fairly durable and kind of well-built machine. It did use linear rails for that Z-axis, and the motion certainly seemed very smooth. You can see it has dual extrusion, so maybe some capability there for multi-material, but because it's not IDEX, you again risk purge blocks and stray filament and things like that. The model that was a little bit more interesting to me is the one just to the left of it. Now, this one didn't have the enclosure on, but there was a version of this with an enclosure around it as well, which again, very interesting for me. What I should have mentioned actually on the first one is that bed moves backwards and forwards and up and down, and then the head just moves left and right. A kind of strange arrangement, but there you go. That's what it is. So this model on the left then, it does still retain a lot of similar features to the first one, but has some upgrades in terms of, I think it was a Raspberry Pi integrated with a touchscreen, running Repetier host, so that just gives you some extra kind of Wi-Fi capabilities. Overall, the frame was just slightly nicer. It had enclosure capability and things like that. So just a couple of little upgrades there. At the end of the day, they're designed for kind of industrial use more than home use, so they are, again, on the slightly pricier side. But if you're looking to move away from cheap Chinese printers and maybe you're looking to get something that you can rely on to print consistently, then this might be one of those options for you. It has a filament flow detection, so basically filament run out, just to make sure that it is moving. Not only does it detect whether filament is there or not, but also if it's jammed. So if it is jammed, it can maybe try to push harder, and then if it doesn't succeed, then it will retract the filament and try again. If that doesn't succeed, it will stop and pause the print and wait for you to address it for a number of hours. They do claim it to be 34 decibels, so a really fairly quiet machine, which is nice. The bed is a flexible steel sheet, so for me, one of those standard features, and it's good that it's there. Unlike the basic model, this one does have auto bed leveling, so you don't have to use the screws anymore. I think it was an inductive probe that they're using to do that. So in general then, just so you get an idea of the basic specs, they're 235 by 244 by 235 build volume, so on the larger side, moving towards larger but not being absolutely massive. You can actually have up to 2 print heads, extrusion speed of 18 cubic millimeters a second. The spec on the sheet actually says 18 cubic meters per second, but I don't think that's going to be the case. Maximum speed of up to 450 millimeters a second. That I do want to test. That sounds crazy. I don't know how they're doing that, but that's pretty cool. Layer heights between 50 and 350 microns. I mean, that's standard for a 0.4 nozzle. In fact, they're using a 0.35mm nozzle as standard, so that's a little bit different. Bed goes up to 105 degrees Celsius and the nozzle up to 275. So presumably that's still an all-metal hot end though, so not too bad at all. Overall, they are definitely more expensive machines again, more meant for the industrial market than your home user, but if you're looking for something that's a little bit higher quality, then this might be what you're after. I did have a chat with them and they did perhaps show some potential of being interested in having one reviewed, so maybe in the new year or later this year we'll be able to take a look at one and see what we think. Next we're going to talk about XYZ Printing. Now, I didn't really talk to them at all. In fact, I only spent a short number of minutes at the stand. I thought their printers looked pretty cool, but there actually wasn't anyone that seemed very interested in talking to me, so there you go. That's what that is. This one in particular seemed pretty nice. It's fairly large build volume, all enclosed, probably very expensive. So I didn't really get too much interest on that one. Also, right next to it, it had this kind of filament enclosure box, which I don't think was heated, but looks like it would hold a couple of spools and would just help with hydration or hygroscopic filaments, which would be absorbing moisture. Again, probably quite an expensive solution to quite a simple problem. The last thing they had, which looked kind of interesting, was a selection of these kind of resin-based printers. I think mostly DLP. You can see a smaller one in the background, very similar looking to photocentric designs, and then this one right up front, which looks more like the Elegoo one. Although this build volume seemed significantly larger. I mean, not like significantly significant. It was definitely bigger, but it wasn't that big. Again, don't know anything about prices, but if it's something you're interested in, then maybe you want to go and have a look. Last but not least is this lovely little 3D printed gadget that I had for the show. Obviously, this wasn't really exhibiting at the show, but it was at the show, so I thought I'd include it because I thought it was pretty cool, and a few people asked about it while I was there. So for filming the show, I used my DJI Osmo Pocket, which is an excellent camera, I think, for doing this, just because it is so lightweight and can still record in really high quality. Now, for filming shows like this, often you don't need the very best quality. I think carrying around a GH5 at a show like this was going to be too much kind of strain on me to be able to kind of record things effectively. It's just too heavy and makes me very tired very quickly. But this I could walk around with for days without being even the slightest bit uncomfortable. However, the battery life is quite short. Well, as it turns out, not as short as I thought it was going to be, but it is fairly short-ish. Over a full day, if I was to really be recording a lot, I would definitely need an extra battery, but for the kind of hour or so that I needed to film while I was there on each day, it actually was not too bad at all. However, I wanted to make sure that I was prepared before leaving, so I designed this small mount for a fairly lightweight external battery. The battery in the camera I think is about 875 milliamp hours, which is quite small, but again, it doesn't use that much power. But this had like 5,000 milliamp hours, so this would be more than enough battery power in the event that the one in the camera was not enough. As it turned out, it was fine. I didn't really end up using it. I think on the second and third days I didn't even put the battery in there. I didn't bring it with me, or I might have kept it in my bag. But either way, the actual mount itself worked really well. It's just zip tied to the frame, and it's tight enough that it holds it in there and I don't have to worry about it. But if I just need to slip the battery out, then I can do that. They slide up and down the legs fairly easily. But even while it's in there, I can see the battery indicator and plug things into the top, such as obviously the USB-C to plug in the camera. That is definitely it now from me for TCT Show 2019. Don't forget to like and subscribe if you want to see more. And if you want to support the channel, you can do so on Patreon. If you'd like to see me do more exhibitions, leave a comment down below or send me a message on Twitter. Thank you very much for watching, and I'll see you in the next one.